All right, in today's video reference, we're going to continue with the Pythagorean theorem, but we're going to use it for something a little different, where there's basically a way that you can use the Pythagorean theorem to find the distance between 2 points on a graph, and then you can use it to test if something is a right triangle. So basically, looking at these graphs here, 1, 2, 3, and 4, we're going to just figure out the distance between these 2 points for all of them. So the steps are pretty simple. You use the 2 points or the line segment to form a right triangle using the line segment as the actual hypotenuse. So it's always a missing hypotenuse question. And then count the units of the leg and perform the Pythagorean theorem to find the distance of the line segment. So we'll start with number 1. Can someone tell me why number 1 you probably don't even need to use the Pythagorean theorem if you want to find the distance between this point and this point? Yeah, it's a straight line. You can just count it. So for a scoosh, can someone count the distance from here to here? 1, 2, 3, 4, 5, 6. So the distance here distance is 6 units. All right. Going on to number 2, so here's our first example of we can't actually just count boxes because it's on the diagonal. So you can use the Pythagorean theorem in a number of different ways to form a right triangle. Depending on how you look at it, you could use this right triangle here and make those your legs, or you could even look at it this way and make those your legs. But regardless, like for example, let's just use the red ones. This could be your A, your B, and the line segment that we're trying to figure out is your hypotenuse. So let's do this one. A squared plus B squared equals C squared. Raise your hand. What's the length of A? Yeah, 3 squared. Plus, and how about the length of B? Yeah, 10 squared. And then you do the Pythagorean theorem like we've all become so good at. And this is 9 plus 100 equals C squared. So this is 109 equals C squared. And can someone tell me in your calculator what that gives you? Yeah, I would say about 10.4. And again, if you look, obviously from here to here is 10, and we know that diagonal is a little bit longer than that one. So 10.4 actually makes a lot of sense there. Let's go on and do number 3 together, and then I'll have you try 4 on your own. So for number 3, the way I'm going to look at it here to make my right triangle, I'm going to do it this time in blue and do the upper part. So then I'll label this A, B, and C. Can someone tell me, as I write the Pythagorean theorem, what the A squared plus B squared part would be? Yeah, so I got 3 squared plus 7 squared equals C squared. So I have 9 plus 49 equals C squared. And then this would be 58 equals C squared. Raise your hand if you can give me the length using the Pythagorean theorem. Yep, 7.6 is the length from there to there. Moving on to number 4, I'm going to pause the video and either by yourself or with a friend, can you find the length there? Great. So someone raise your hand and tell me what you get for number 4. Yeah, I get the same thing, 6.32. So I did this 6 by 2. So it was 40 squared equals C squared. I got 6.3. All right. So that's not too bad, again, because when you do these are all missing hypotenuse questions. Then another thing that you can use the Pythagorean theorem for is to test and see if this is a right triangle. So test to see basically when you're given lengths if it's a true statement. So test to see if A squared plus B squared really does equal C squared. Then it's just a yes or no question. Either is a right triangle or it's not. So let's go ahead and let's try number 6 and 8 together, and then I'll have you try 5 and 7 on your own. So now nothing's missing. We're given the three sides. And so if we do this, this would be A. This is my right angle, sorry. So this would be C, and this would be B. So now I'm going to actually plug it into the Pythagorean theorem to see if this is true. So I'm left with 12 squared plus 5 squared equals 13 squared. Raise your hand if you can maybe tell me all those squares. 144 plus 25 equals 625. I'm sorry, equals 169. Yeah, that last one you probably didn't know. And actually this plus this is 169. So it's a true statement. So it's a yes. It is a right triangle. All right, let's look at number 8 together. So this one actually tells you A, B, and C. And obviously you know this is correct, that this is your hypotenuse, because out of all the numbers, 9 is definitely the biggest. So now we're going to go ahead and give it a shot. So we're going to plug it in. 6 squared plus 8 squared equals 9 squared. This is 36 plus 64 equals 81. 36 plus 64, let's see here, 36, 64, 6, 7, 8, 9, 10 is 100. So 100 does not equal 81, so that is false, so this would be a no. Basically, there is a list of perfect Pythagorean triplets that I want to quickly show you. So again, these are all ones that come out perfect. So if we go back to number 6, 12 by 13 is right here. So we have, hold on, I'll find it for you. Right here, 12 by 13 and a 5. So 13 is your hypotenuse and 5 and 12 are the legs. So I hope that helps you, and give it a shot.